Hi, my name is Hyunwoo Kim. I am a first one-year master student in PRML lab working with Dr. Lee. Let me present my research progress and plan. I'm currently working on a golf project in conjunction with a company. By combining human pose estimation that identify human joints and GolfDB, this paper. Our goal is to compare and inform the consumer posture with the correct posture about swing. GolfDB defines a sequence of a golf swing as 8 specific movements and taking golf swing video as input, 8 particular movements with labels as output. The goal of this project that I think is to develop a digital AI golf pro coach that recognizes and manages each consumer's swing behavior through 3D human pose estimation and action regression by inputting the front and side positions in a dark environment such as a screen golf place. I think it's a pretty good project business because it's expensive to play golf outdoor real field in Korea. So the indoor screen golf place is developed well in Korea. And so therefore I think the company can make a good profit if the machine or our model in the future is supplied to this green golf place a lot. GolfDB, which is briefly introduced above, is not a human pose estimation. Is not using human pose estimation that output human joint key points information. Recognizing actions such as GolfDB paper and outputting each action will perform better if we use human pose estimation, and I think it will be more well explainable. So I am currently studying human pose estimation. I quickly read the following survey paper to understand fields as a whole. This paper describes human pose estimation as follows. Human pose estimation is localized body key points to accurately recognizing the postures of individuals given an image. And human pose estimation is one of the challenging fields of study in computer vision which aims in determining the position or spatial location of body key points of a person from a given image or video. This paper consists of the following first basic step. First, this paper briefly explains the basic step of pose estimation and explains the uh, methods, approach, application, and challenges faced by pose estimation. This paper introduced backbone, loss function, dataset, evaluation metrics, which are the main components of pose estimation, and the major researches 13 papers in human pose estimation. The main process of human pose estimation is boiled into two basic steps. One is localize human body joint key points, and two is grouping those joints into valid human pose configuration. In the first step, the main focus is on finding the location of each key point of human being as displayed in figure 2. The second step is grouping those joints into valid human pose configuration, which determines the pairwise terms between body parts as in figure 3. Next, pose estimation primary. Human pose estimation can be divided into single or multi-person as shown in figure 4. It can be also divided whether it is a top-down approach or bottom-up approach. Top-down approach is the processing done from low to high resolution, follow the detection of the individual instances in the figure, first using a bounding box object detector, and the focus on determining their pose next, as shown in figure 5. Their approaches always suffer from early commitment, which means if the detection of individual fails, there is no possibility of recovering. Furthermore, the computational cost depends on the number of people in image. The bottom-up approach's processing is done from high to low resolution. It starts by localizing identify free semantic entities and then grouping them into perform instance. Bottom-up approaches overcame early commitment and showed detached runtime complexity from the number of people in the image of shown in figure 6. In addition to that, some researchers using bottom-up approach use the global contextual cues from other body parts and other people. However, bottom-up approach face challenges in grouping body parts when there is a large overlap between people. Next, the application of pose estimation. There are human pose estimation application areas such as action recognition, human tracking, animation, and gaming, and also video surveillance, assisted living, and advanced driver assistance system (ADAS) are included. It may also provide game analysis in sports by describing the player's movement. Pose estimation is also applicable in sign languages to help disabled people. Changes facing as position are position and scale of each person in the image and barely visible joints and crossing, lighting changes, contact occlusion of individual parts by crosses, background limb architectures. Main components of pose estimation are backbone architecture and loss function. It is said that pose estimation uses mainly AlexNet, VGGNet, ResNet as backbone network. And it is said that pose estimation uses MAE, MSE, and cross entropy loss as loss function. On dataset, this field mainly use dataset that are FLIC, LSP, MPII, human pose, COCO dataset. And so as shown in figure 2, different platforms can result in different dataset output formats for the same image of body joints. So because data formats are different like this, we need to know what data the model used. And the evaluation metric include PCP, PDJ, PCK, PCKH, etc. And additionally use AUC, AKS, and MP, AP, MAP, which are used in other fields. Finally, this paper summarize and explain the following 13 papers. So I will read the multi-view human pose estimation papers that I am showing you now, and I will read about mesh human pose or 3D human pose. Follow now on my research plan and progress are planning to learn human pose estimation and study multi-view human pose estimation, and after that 3D human pose estimation through this both project. In addition, Apple recently released the Apple iPhone with LiDAR sensor. Therefore, I think this will make it easier for individuals to get 3D information of objects or human. So I want to study 3D avatarization through 3D pose estimation from multi-images or multi-views with LiDAR sensors, and applying it to virtual try-on or fashion feed or fashion AI. Therefore, as you know, are looking at now, I think I will read the following papers and related paper. The paper relating to LiDAR sensor, 3D and point cloud, and fifth papers and related paper. I will find those and I will read, and I will read several virtual try-on paper. In other words, my plan is to study human pose estimation during this project by October, concentrate on this project and study thoroughly. Also, I will read point cloud related papers using LiDAR sensor or 3D point cloud and looking for research related to human pose estimation with point cloud. And my plan is to learn paper in those fields as much as possible by December this year and start research to apply them together. The point cloud mesh, human pose estimation, multi-human pose estimation, 3D human pose estimation, avatarization, etc. All together I will apply from next year. So my PPT is all. That's all. Thank you to listen my PPT. Thank you.